So we're going to move forward with this idea of changing amounts from one unit to the next unit. Okay, so in order to change things from one unit to the next unit, we need a conversion factor. So pause here and see if you remember conversion factors that help us just change units, but not change the amount. There's a couple things that are always true about them. What are those things? Say that again. Equivalent. They are equivalent, yes. So the top is usually equal to the bottom, sometimes only equal in a specific circumstance, but yes, top is equal to the bottom. That's thing number one. What else is always true about conversion factors? They have a top and the bottom, right? And are the top and the bottom same units or different units? Different. So they have 2 units. And they're a fraction. They can be written as an equivalent statement. They can be written as a fraction, right? Okay, so as we move forward in using this, let's just pause for today and try and think of conversion factors we already know. And then we're going to put these conversion factors on cards for a reason, and I'm going to show you what that reason is after we do the first one. Okay, so let's start with the easy one. We know SI units. Now, I don't know if we've ever called them SI units, but as soon as I kind of go through these things, you will know what I'm talking about. For example, if we're dealing with length, what's the unit that we're going to be using? Good guess. If we were in the United States, we would use inches. If we were anywhere else in the world, we would use meters. Yes. Okay, so meters, sometimes it's convenient to measure things in meters, but sometimes it's not. If we're talking about the distance from here to Michigan, and you tell me it's 7 million meters, I'm going to be like, I have no idea what that means. What would you tell me instead of meters? Kilometers, yes. So also measures distance. We can talk about the same distance, but in kilometers. So we can get bigger to kilometers, or we can go smaller and talk about centimeters, millimeters, micrometers, or micrometers, right? This is the SI system, the International Scientific Community System, right? And I bet you already know a lot of these. If I have 1 kilometer, how many meters do I have? Close, 1,000. Right? If I have 1 meter, how many centimeters do I have? 100. Let's do all of these. If I have 1 meter, how many millimeters do I have? So milli, think of, does anybody speak like Spanish or French or Portuguese? What's 1,000? Yes, and it starts with MIL, right? So that prefix MIL means 1,000. So it's 1,000 millimeters in a meter. And then micro, a micrometer or a micrometer is 1,000,000. So 1 times 10 to the 6th. And micro is a weird letter. It's like a cursive U that has a front tail. It's a mu. It's literally its name, MU. Okay, so some of these we know already. Some of these we're at least familiar with. We've heard of these before, right? So there's more than just the 4 I listed on the board. But these are the ones that are especially useful in chemistry. So let's just deal with this. Well, notice I've written them all as equivalent statements. we can write them all as conversion factors as well, right? So if we're going to write if we want to convert between kilometers and meters, let's say from here to Michigan, I'm not going to be able to ballpark this. From here to Winco is 2.2 kilometers. If I want to convert that into meters, same distance, communicated in a different unit, right? I'm going to multiply by a conversion factor. And this distance changes. Here to Winco is 2.2 meters. Here to Michigan is a different distance, right? But my conversion factor never changes. That relationship between meters and kilometers never changes. I'm going to put kilometers on bottom because whatever unit is on top automatically goes on the bottom so that they reduce out, right? And then meters goes on the top. And then I can think through my numbers. 1 kilometer, 1,000 meters. So we know the SI units. We can write them as conversion factors. So this is where this little beast comes in. I'm going to write a conversion factor specific to meters and kilometers, but you can do the same thing with any of these other ones, right? So if I put 1 kilometer on top, like I've done, right? What I'm going to do is I'm going to flip it upside down and write 1,000 meters. I'm doing it on a big card so that they can see it. Yes, you're supposed to rip them. Yes, because you probably don't want big. It's better to have little cards. So notice how like I can flip it either way and the top is always readable. Yeah, so that's how I want you to write it. I can flip it either way and the top is always readable. Because if you write it like this, you can do something special with it. And I'm going to show you that something special on the board. Okay, so for example, we're going to do a lot of these conversions, right? Well, if you're doing this conversion from kilometers into meters, you know you want to find a card that has these 2 units on it. Every conversion factor has 2 units, right? So I'm going to look through my cards. Do I have one that has kilometers and meters on it? Yeah, I do. And then this can help me decide which one goes on the top and which one goes on the bottom, right? If I have kilometers, do I want kilometers on the top or do I want kilometers on the bottom? On the bottom, right. So then I can write 1 kilometer on the bottom, 1,000 meters on the top, and it's set up. But if I start in meters, I want meters on the bottom, right? 1 kilometer, 1,000 meters. So we're going to write these cards so that they can help you get unstuck. If you can write the thing that you're trying to convert and what you're trying to convert it into, your cards can help you get the middle portion. That makes sense? Okay. Now we did write this SI unit 1 very specifically. So on the back, it might be worth taking a minute and being like, also meters to centimeters, meters to millimeters, meters to micrometers, right? so that we don't have to make, you could make individual cards for all of them. Okay, another conversion factor that you probably already know or know about is density. What is density?
I don't know how to explain it. It's like,
if I have 4 balloons in this room, my room is not very balloon dense, right? If I have this whole room filled up with 3,000 balloons, my room is more balloon dense. So it's the number of things in a space. So when we talk about density, usually we talk about the number of things in terms of mass, and we talk about the space in terms of volume. So density is grams per milliliter. Now, is the density of cotton going to be the same as the density of copper? No. Every specific thing has its own density. So unfortunately for us, there's no periodic table piece of information that tells us density. If you want to know the density of something, you have to look it up. But look at this. 2 units in a fraction. And if I know the density of something, like the density of water is 1 gram per milliliter. So I can write it as an equivalent statement. 1 gram of water is equal to 1 milliliter of water. So it can be written as an equivalent statement. So I would take your next card, and I would make a little fraction for density. If you ever need to convert between mass and volume, or grams and milliliters, you may be able to use density. If you know the density, like the density of water, or if you can look up the density, like the density of metals. Density of metals are very consistent. If you go look up the density of something, you can actually identify the metal that you're talking about just by figuring out its density. It's not always true for other substances, but metals are very consistent. Okay. Oh no, I didn't mean to do that. 1 SI units to density. Okay, there's one more that's kind of common before we get into the chemistry stuff. And you might not want to make a card for this. You might just want to keep it in the back of your mind. If there is a conversion factor that you can make up for your context, you can use it. Like yesterday when we did the millet seeds, 100 seeds was equal to 0.85 milliliters. We actually made that up ourselves. We went and measured it. We calculated it, right? We counted out the seeds. We put it in the graduated cylinder. So it's true for us and millet seeds. You're allowed to use that as a conversion. What would we use that to convert between? What 2 things?
Milliliters and grams?
Seeds
and milliliters.
And milliliters, right. The 2 units that are in there. We would use it to convert between seeds and milliliters. Or we could make one up for our classroom right now. We have 4 people in one class. That is true for our context right now. So you can make your own up, or maybe I should say measure And those are legal conversion factors. Okay, now let's talk about the chemistry ones that we have. Can you guys think of chemistry equivalent statements that we have? Can you think of any that we have? I have a hair in the mask, and it's driving me crazy. Oh, I found it. I think I found it. One we talked about last week. Two we talked about last week, actually. I'll give you a hint.
All right.
So what is the unit on that? 6.02 times 10 to the 23rd what? It can be element. Yes, anything. Yeah. So I'm going to put things because technically we can talk about anything. We can talk about elements, ions, atoms, molecules. We can talk about millet seeds, donuts, or elephants, right? So what's the other half of that? Equals what?
Not AMU.
Not AMU. Although we could do that one too. We'll keep that one in mind.
Okay.
So 6.02 times 10 to the 23rd things, you're close, equals 1 mole of those same things, right? It can be atoms. You could say 6.02 times 10 to the 23rd atoms equals a mole of atoms.
That's how I have it here. I have like an atom, and then I have like a mole as well.
But it doesn't equal one atom. It equals a mole of a group of atoms, right? Okay. Yes. We have another thing that works off 1 mole. We do. We have a second one. I'll give you an example. 1 mole of carbon equals, what's the other thing we can go to from moles?
No.
You're so close. Not AMUs. You're so close. What? What? I just didn't. Grams, yes. So for carbon, it's 12 grams of carbon, right? So 1 mole of something, of an element, or a molecule, or an ion, equals the mass in grams of that thing. And that is from the periodic table. So we can go from moles to grams using what's on the periodic table. Yeah, okay, so take a minute, make yourself 2 more cards. So you're going to put moles on the top of one, and then 6.02 times 10 to the 23rd on the bottom. And then in a different card, do moles on the top again, and then grams from the periodic table on the bottom. And again, this can be elements, molecules, ions, anything that you can build its mass from the periodic table. Okay, now Emma brought up an interesting point. If you use that same mass from the periodic table, but you're using it in AMU, you don't have one group of atoms. What do you have? One atom. Yeah. One thing. So again, thing can be element, molecules, ions. Right.
So how would we write it
On the card?
Yeah.
So I would do, for which one? 4, 5, or 6?
I think it was for 5.
For the mole to grams?
Yeah. Would
So-
we just write it 1 mole equals how many grams?
I would do 1 mole of a thing, and you might even want to make a note that that thing can be elements, molecules, ions. So 1 mole on the top and then flip it. And on the bottom, I would put blank grams of things. And then make a note that that's from the periodic table. That mass is from the periodic table. All right, there's one last one. And actually, you guys, are you out of cards over there?
I got 2.
Oh, you have 2 left?
Yeah.
Okay.
Yes, please.
I do have more yellow if you want to keep them coordinated.
These are really fun.
Okay. And it's kind of on the same line as the one we just did, as number 7. If I give you a compound, let's say I give you NaNO3. Oh, that's a bad example. Well, I'll do that one. NaNO3, sodium nitrate. If I have one compound, how many oxygen atoms do I have?
3.
I have 3. Right. So what you can do is you can go from compound to atoms in the compound. So like 1 NaNO3 equals 3 oxygen atoms. Now, some people really don't like this one because they'll say, well, one sodium compound is not only oxygen atoms, right? But if I say, hey, I'm making that awesome cake you made on your mom's birthday, how many eggs do I need? And you say 2 eggs, 2 eggs for 1 cake, right? You're not going to answer my question and say 2 eggs, cup of flour, teaspoon of vanilla, pink sprinkles, blue frosting, and some candles, right? You wouldn't tell me all the ingredients if all I want to know about is eggs. It's the same thing in this example. In a conversion factor, you're converting between 2 specific things, right? You don't have to tell me about everything that's involved if all I want to know about is those 2 specific things. So this one's a really tricky one. Conceptually, a lot of people don't like this one.
I kind of like it.
But it's legal. It totally works if all you want to convert between is oxygen and the compound. For example, on this one, I might want to burn paper. I might want to burn something in a closed container and know, when is that oxygen going to run out? Well, I don't care about the fuel or anything else that's present, the nitrogen in the air. All I want to know is the oxygen, right? So you can convert between your amount of fuel and the oxygen atoms. or molecules in that example, I guess. Okay, so you're going to want to hang on to these. I can give you guys a baggie if you want a baggie. But as we work this week through examples on this, when you find yourself stuck, try to figure out the thing you're trying to convert, what you're trying to convert it into, and then go look for a card that can get you that middle piece. It's a nice trick that might just help you get unstuck on some of these examples. Okay, so if anyone online has questions, I can answer them. Let me know what questions you have. Otherwise, that is it for today. You guys can have a great day.